name is Laurent. I'm working for the European Commission, more specifically the Joint Research Center of the Commission, which is the biggest Directorate General of the Commission, which is providing scientific support to other Directorate General of the Commission in various fields: energy, transport, information society. We are roughly 3,000 conducting research in all these fields. And one of the mandates of the GRC is to promote and to support research, of course. That's why we are supporting some of the speakers of the academic session we have today in order to help them to conduct their research and produce interesting results for the European Union, of course. So I will immediately switch to the first speakers. I just would like to say that apparently the very first speaker, Vanessa Díaz, is not with us. So we will jump immediately to the next one, Sophie. And please, the floor is yours.
Okay, thank you very much. So what I will try to speak about today is about the buzzwords of metadata, traffic data, communications data. Trying to answer or to give some elements of answers to a question that cannot be answered. What does content of communications mean in the online world? Why is it that I'm asking this question? Because for different types of purposes, if I take the example, for example, data retention, but also access to data, it is at least it is thought to be of relevance to be able to distinguish between what is content and what is the rest, basically, because the scope of the powers will differ in relation to the type of data at stake, right, in principle. Why is that I'm asking this question? So by way of background, we have different views obviously on that issue, and if I try to simplify, I might be oversimplifying here. These are the two extremist views, okay? The dead one, so to speak, I'm not going to give any names here, but the view being that metadata and content data are all the same thing, meaning everything is metadata, and therefore we should have access to everything, okay? The opposite view is that metadata and content data are the same thing, but for another purpose, the purpose being to be able to protect metadata as much as we protect content data, and therefore to have additional safeguards. For example, the proof of suspicion when you have to retain data and when you have to access data, and also to require some kind of legitimate supervision, and in particular judicial supervision. So that's an oversimplification, right? Another important principle that we need to bear in mind when it comes to communication is that we have, at least in principle, in theory, principle that our correspondences, communications are confidential and are protected as such. That is derived from Article 8 of the European Convention of Human Rights, the right to privacy, although it is not expressly mentioned as such. Okay? Also Article 7 of the Charter, Article 2nd legislation, the Privacy Directive, which expressly formulates that principle. Well, that's a principle, and to almost every principle, you have some exceptions. So if I follow the legal logic here, I can have some exceptions, but they have to be interpreted restrictively, and I could do so assuming I have a clear legal basis and with appropriate safeguards. Okay? Do I have more within the legal framework in order to better understand to which extent communications are protected, content, and traffic data? That picture might be the route to utopia, but I hope not that much. At the end of my explanation, I will show why there might be ways to better protect communications. The principle that I've just mentioned is a principle that you find in conventions and in secondary legislation. Now, if I look at case law, for example, to have a better understanding of how the distinction is understood, I could take the case of the European Court of Human Rights, okay, and for that purpose, the Copeland case, which is which deals about emails and the monitoring of internet usage, right? And here, in that particular case, there is an analogy that is, as it seems, that is drawn between the monitoring of telephone communications and the monitoring of electronic communications, such as emails and internet usage. The conclusion of that, if I follow my logic here, would be that the court says that measuring information in relation to telephone communications are an internal part of communications, which would mean that we need to protect not only the content, but also measuring information. And if I apply that logic to the internet, that would have, and we need to have the same for emails and internet users. All right. This being said, further down within that same decision, the court says that the monitoring of communications, which means the collection of measuring information in relation to electronic communication, is an interference in principle to the right to privacy, but of a much lower order of seriousness, which should have some implications in terms of the way we protect measuring information. Okay, but it's not clear how we draw the distinction between content and measuring information when it comes to electronic communications. It's not clear in the cases. It's not so much clear also if you look at what legal commentators sometimes write. If I take the categories that we have in English law, you have a distinction between content of communications and communications data. Okay, and then for I don't know if it's a vast majority of commentators, but they tend to interpret quite broadly the notion of communications data, and basically that would be almost everything but the content of emails. Okay, which would have implication in terms of how you can access the data, in particular if you look at law enforcement agencies. Okay, because we have two types of procedure, and it is easier to access communications data obviously than content data. Okay, so I want you to better understand how we could define what is content and what is the rest. Okay, and for that purpose, the idea was to work in an interdisciplinary team and ask the views of the computer scientists to see whether they had a specific understanding of what is content and what is not content. So this is why I have the view of the nerd here. For the computer scientists, or at least for some computer scientists, they draw a fundamental distinction, and it's a distinction between the payload of a packet and the headers, right? For them, everything that you find in the payload is content, and the rest is metadata, which has some implications in a way, because it is, in a way, more protective than to some extent, the legal understanding of what content is. Because if you look at what you find in IP and TCP headers, you find IP addresses, of course, ports, source port and destination port protocol. But for example, an email, the subject line of an email would be found within the payload, as well as the URL, which would be application data, which would be at the core of the payload. So that would be content data and not communications data. Now, if I confront that view with that of the lawyers, and if I try to find some clues within the legal framework, I don't exactly find that distinction between the payload and the headers. That being said, I'm not exactly sure of what the law says. I've not been looking at all different jurisdictions here, and I'm going to speak mainly about the English system because I think, but correct me if I'm wrong, in a way, the distinction between content and metadata is more important under English law than it would be under French law, for example, where obviously the role of judge is more important in regards to at least access to data. So they don't need that much to draw a distinction between content and metadata. Legal definition, or quasi-legal definition, because under English you have the law and then you have code of practices that are guidelines issued by the Home Office in order to interpret the law and says what it means in practice. Communications data, okay, what is not content data, are divided into three distinct categories. Traffic data, subscriber information, and service use information. And if I look at the definition of traffic data, combining the law and the code of practices, it is everything that is found at the beginning of each packet. Okay, but we're not that clear of what beginning of each packet really means. It does exclude URL, obviously, because it's application data at the very core of the payload. But everything that is before the first slash would be considered as not being content data. I'm being quite technical here, so if you have any questions afterwards, do raise your hand. Emails are included within the definition of traffic data. So it's a bit of a mix, obviously, because the idea is to get relevant information. That being said, the definition is not very clear the way it is formulated. With service use information, once again, definition is quite broad, and at least if I look at the law regulating access to data, it might be different for retention of data. The formulation is broad. Okay, it's everything that relates to the use of a service. Some examples are given, but it is not a closed list. Okay, so potentially that could also reach further information. And at this stage, there is no exclusion of URLs. Okay, the exclusion only is only present for traffic data. Okay, subscriber information that is also of interest, in particular if you want to combine traffic data and subscriber information to reach an individual. Here, everything is basically also very extensive in a way, and it's not clearly stated what would count as a subscriber information. So the legal definitions are there. They're maybe more detailed than in other jurisdictions, but still some doubts persist. To conclude and to come up with some elements of answers, although it's a work in progress, so that's not going to be definitive. We've argued, myself, to try to come up with some criteria to try to distinguish between different types of data in relation to their degree of privacy concern. And we came up with 3 key questions that we need to be asking in order to classify the data. Okay. We came up with this idea that it's important to determine whether the data is within the payload or not. Why? Because in order to fetch the data, if the data is in the payload, you will need to implement specific technology that is sort of intrusive and quite heavy to implement. Deep packet inspection technologies, the kind of technologies that are also used for blocking purposes, all right? That could potentially, and also for network security purposes, in order to detect malware. They look into content of the communication. This is a violation of rights for confidentiality. I don't know, but so if the aim is to avoid the creeping extension of DPI, then that's a relevant question. Can these data directly identify individuals, and can they directly reveal sensitive information? And these are also important to try to classify the data. So these are our categories of data, and we came up with 4, maybe 5 categories of data. The most important are here. Network level metadata, the information that you find in the headers, IP headers and TCP headers. Application level metadata and content data are found in the payload. Okay. And then service use metadata are the metadata that are found on the server side, okay, and could potentially mirror the network level metadata or the application level metadata or eventually content data. So we need to be aware of 2 types of data here, data in transit and data stored on systems. So the activity of the service provider is quite important to identify if we want to really understand which data are at stake here. And to wrap everything up, from this classification, then some questions arise, and in particular, should we treat metadata and content data alike for retention and access purposes? If not, how do we discriminate between different types of data? All right. And if we think that network level metadata raise a privacy concern of a lower degree, isn't it the case that when they are combined with subscriber information, then we need additional safeguards? Because at this stage, we are really trying to directly identify individuals. And the last question also would be to try to distinguish data in transit and then data stored, and say that if data retention obligations are invalid, there are also other concerns, in particular if it is possible for ISPs to look at the data while in transit and make decisions at that stage, and then only retain suspicious data. That is quite the aim behind that is the same as the aim that justify data retention obligations. Okay, although the technology and the way to do that is slightly different. All right, I think I'm finished.
Thank you, Sophie. Is there any questions you would like to raise, and clarification, or even comment if you want? Yes, please.
Hi, my name is Joe Cavan. I'm from the UK Intersection Commission's Office. So we're responsible for overseeing public authorities' use of these powers. So I found your presentation fascinating. And it's really good to see that someone's working on actually trying to come up with new categories of data. I'm not sure whether you saw, we recently published our response to David Anderson QC's review, and we put some examples in there of where the current categories don't work anymore.
Right.
A lot of the new technology, so you might find that interesting. But equally, I think it's a really good opportunity for research like yours to actually contribute to the reviews, because we've got sunset clause, as you know, in the UK in 2016 December, where we have to have new legislation in this area. I particularly like your comment around it's important what the network has to do, and I think that's why the categories we've got currently don't particularly work, because it's not just about looking at the type of data, but about what the network has to do in order to retrieve that data. So I'd be quite interested to talk to you a bit more about that. And my question really was, you mentioned these 4 categories, and also that you were looking at the confidentiality and privacy around some of the data. And I mean, what do you think is important? Is it about the privacy and the expectation that customers might have about that data being released, or is it more about the network's activity and the equipment that they deploy to bring that data back?
So you're opposing privacy.
So in terms of the legislation, do you think it should focus on the privacy implications of the data, or on actually in terms of the ethical side, or in terms of the networks and the activity, and in terms of the equipment they're using and how they're mining and pulling out that data?
You mean in terms of network security practices that they are developing in order to secure the network. I think you need to address both at the same time. Because if you look at, for example, the e-privacy directive and the way it has been, well, in practice, this is what I'm being told, is they are looking at the payload and the content in order to detect malware. So this is what they are doing basically. So it's a bit of a, it's appropriate to say we have a principle of confidentiality, and therefore they say that this is something that I think you find under French law that for network security purposes you can't look at the content. So you have a law here and the practice is here. It just doesn't work. I mean, if you want a clear legal basis and a clear legal framework, it just doesn't work. So I think you need to take into account the privacy implications, and it's why I think it's very important to distinguish between different types of data, because they're not the same thing. And the next step would be to apply that to location data and see to which extent there is a variety of different types of location data as well. So try to identify, it's very difficult obviously, to identify the privacy concern raised by each type of data, and also to take into account the necessity of ensuring the security of the network. Yeah, I think you have to take both into account.
Thank you again, Sophie. Let's move to the next speaker. Tilman, please. Okay, the floor is yours.
Thank you. Move over to the side. Yeah, that's for the introduction. This is John's work with Sven, Schäge, the topic is location privacy in the absence of anonymous payments. We make
Jensen, Michael Jensen, and I work at the Independent Center for Privacy and Data Protection, which is in Deutschland, Germany. And what I was wondering about the scenario that he chose here is that you have these charging stations of one operator, and these charging stations are used for charging cars or something, and then submitting the charging data and the billing data to some central backend. So did I get that correct, that the idea of your approach is to hide the exact charging station instance from the clearinghouse that actually takes the billing data? Or is it that several operators with several different places and several different aggregation centers are exchanging the data, and you want to protect the others from learning the data position?
So we oriented this approach around something that's actually happening. This is the first scenario. So we have, this is currently, it has several solutions and several in concurrence there, and we'll see who actually gains leverage there, but this is the first scenario. And we're also, of course, hiding location data from the actual utility. So this is.
So that means that the operator who is putting the charging stations in place is also the one to deploy the infrastructure you've shown with the signatures.
Signatures would be rather yes, of course. You have as in the when you go into the certificate structure in there, you have something that the clearinghouse would be a root entity here, and you have intermediaries on the level of the individual utilities.
So that basically just means that the signatures can be used to hide the location of particular customers from the operator itself. So he's actively taking measures by applying these signatures to hide this information from himself. Is that the result?
In the end.
Okay.
So yeah. So the argument towards the vendor is rather that we're solving a different problem parasitically. Because we're actually providing authentic and non-refutable billing data source to sync, which is something that in Germany, for example, only one vendor so far has managed. And this is something that should be relevant as soon as some customer questions the bills.
Okay, thank you. Let's move to the next speaker. Tony, the floor is yours, please.
Okay, good afternoon, everyone. I'm Tony Morton from University College London. Now, the quote entitled on my paper here is from a book by Douglas Adams. And I don't know if any of you read Douglas Adams' books, but I strongly recommend you do. But it's from a character of his called Dirk Gently. And Dirk Gently is what he calls himself a holistic detective. So he's really interested in the fundamental interconnectedness of things. So, for instance, the sudden disappearance of a cat might be eventually linked to a murder. So what I'm going to argue here in this presentation is I think when it comes to privacy failures, we need to be a bit like Dirk Gently and take a holistic view. So By virtue of the fact that you're at this conference, I'm sure you're well aware of these instances that have occurred over the last few years of what I call privacy failure. And there's been adverse publicity of either potential or actual loss of people's privacy because of technology. So, part of my research, I'm really interested in organisational privacy practices and how that influences people's privacy concerns. So, it then made me start to think about, well, what are the root causes of these privacy failures? So, is it a software release management failure? And in the case of Google Street View, Google claimed at the time that it was legacy code on the operating on streetcars that accidentally swept up all the Wi-Fi data. And maybe it was a software release management failure. Is it a fundamental information security failure? So this idea of loss of privacy due to security breaches, which happened in the case of Sony and Choice Point and companies like that, again, well documented. Is it an interface design failure? Is it just a simple case that the interface that the user has to deal with is just so complicated that they don't understand what they're sharing or not sharing, as happened very graphically with peer-to-peer clients, where people were accidentally sharing very personal information about their life. Is it an ethical failure? I mean, many commentators have looked at some of those instances and said, actually, we don't believe the company's intentions were benign. We think actually that some of these actions were deliberately malicious. Is it just simply a failure to appreciate different stakeholders' perspectives? So, I know in one of the previous panels, people have talked about the launch of Google Buzz and the fact that they appeared to make the assumption that people were quite happy that signing onto what people saw essentially as being an email client suddenly enrolled them in a social networking service. So maybe they didn't appreciate that people see Gmail just as an email client. So, okay, you can see from just some of these examples, and there are many more types of failures, but we need an interdisciplinary approach, because all these different failures happen at very different levels in what I call the privacy practice stack. And I'll describe that a bit more in the next few slides. So we need this interdisciplinary approach. So what can we use then to look at failures in this way? And thankfully we have something, and it's called the systems failures approach. And it was developed by the Open University in the process of teaching graduate students and undergraduate students about how to look at systems failures. And they looked at IT systems failures, but also general failures, things like building of bridges, why projects were late, and those kind of things. So it isn't just IT systems failures. And their work is based on this idea of soft systems methodology, which was developed by Peter Chetland. Have any of you come across soft systems methodology? Okay. Soft systems methodology is a fantastic technique. The problem is people tend to see the word systems, particularly if they're computer scientists or engineers, and go, oh yeah, I know all about systems. The key word here is systems, and effectively what it's saying is, it's not a system in the sense that we understand a system. You look at a problem situation as though it were a system, and by using system techniques, you can explore, so effectively you have a learning system, you explore what the root causes of that situation are. So it really came out because Peter Chetland looked at hard systems engineering methods, which were fine if people knew what the problem was and just wanted to know how to solve it, which I think is probably the classical systems engineering approach we all know. Soft systems sort of takes one step back and says, I don't actually know what the problem is, let alone try to solve it. I need to understand what the root problem really is. So it's that step backward. More hopefully it'll become clearer as I progress through. So soft systems are fantastic at looking at what Chetland would call messy and complex problems. They're things that you really take a lot of effort to analyse and get to the root cause of the problem. So what I'm contending is I think we should start to view privacy failures as systems failures and use systems failures approach to try and work out what the root causes of those problems are. So what's a system? So I've said that systems aren't computer systems, IT systems. It's basically a transformation process. So Chetland said, look at it as a transformation process. So it takes, very simplistically, some input and then outputs in a transform state. So I'll go forward to this one. Here's an example. So an information security system takes in very simply unsecured information assets, and its output is secured information assets. Now, it's a very simple view, but essentially that's what an information security system does. One of the critical things with soft systems, though, is this idea of worldviews, and it's the subjective interpretations of a system's purpose. So this worldview, and there's a German word, and I apologise now to anyone who's a German speaker. It's Weltanschauung, I think it's pronounced, but it's the German word, which means a worldview. And the reason that's important is people have different conceptions of what a system does. So, for example, to pick a trivial example, a lending library. Some people might say, well, that's a system that takes the local population as an input and it outputs a better informed local population. Someone who has to provide the budget for books probably sees it as a system that takes nice new shiny books in and produces scruffy, tatty, worn-out books. There's two different sections of the same system. So the systems failure approach then is based on this idea, and it has this really interesting technique called the formal system model. And the formal system model basically says, if you think of a system, a formal system is effectively a robust system that is capable of purposeful activity without failure. So by the purposeful activity, what I mean is the transformation process. It has a reason for being. It has a reason. Checking had this idea of a formal system model as well, which in latter years he's dropped, but the systems failure approach technique still kept it. And the idea of the formal system model is, if you model the problem situation as though it was a system, and compare it with effectively like an ideal system of how an ideal system should work, then when you can start to see where the breakdowns are in communication paths between the components of the system, then you can start to potentially see where the root causes are. And in fact, this isn't all just theory by any means. Again, two people from the Open University have created this thing called the project-specific formal system model, and it's been very useful to look at projects, very large construction projects that have gone wrong, and they've modelled the situation using a project-specific formal system model, and then compared that with how it should operate, and could then see the breakdowns. So this is a very simple sort of stylized view of the systems failure approach. So out here we've got the real world, you've got the problem situation. So to think of privacy, the problem situation is a privacy failure. So you then have to decide, well, what constitutes a failure? What do we actually mean by failure? It could be inadvertent sharing, and then because of that, you then choose what system we're going to represent in something like the formal system model. But there are other techniques, the formal system model is just one example. And then you do this comparison to compare your modelling of the problem situation with this ideal model. And then what might come out of that is better understanding, and it might be something as simple as you just redesign the interface according to the tenets of privacy by design. I mean, that's a really trivial example, but you can see how the real world and the systems thinking way sort of fit together. So this is the formal system model, and it consists of a system, which is this thing I talked about earlier on, and it has a transformation process, and that consists of subsystems that carry out the transformation, and a decision-making subsystem that controls the operation of the system, and that's the thing that decides on what transformations need to happen, provides resources, things like that, and then monitors the performance of that system. This system then operates within a wider system, and then the wider system is then influenced by the environment. Now, what's interesting is the wider system cannot influence the environment. So if you've got here, it says attempts to influence. So it can attempt to influence the environment, but it can't directly control it. So, which is why things in the environment disturbs the system. So I just want to step back for a minute. I did a paper in 2012 for the Use of Security Paradigms workshop, which said, well, hang on, let's look at privacy practice for organisations as this privacy practice stack. And the idea was it then had information security at the bottom, information management, information principles. I know on this conference we talked a lot about data protection. So data protection sits in there really. That's the length of the law within information principles. But also companies should go above that and have the spirit of the law as well, should exceed their legislation. There's information use, and then what I call the information privacy culture, which is the intersection of the information ethics of the organisation, the information security culture, and the information culture within the organisation. And the idea is each layer is required, but each layer rests on a layer below, requires services from the layer below, and requires services from the layer above. So and these are split into the top sort of 2.5 here of what I call privacy influences, and the bottom 2.5, I'm splitting information principles here, are privacy hygiene factors. By hygiene factors, I mean these are things you absolutely have to do to even be serious in terms of privacy, even be in the game. So this then is obviously carried out by a providing organisation, and they offer their services, whatever it may be, through what I call a technology lens, which is the technology platform, so that might be a website, and then a whole lot wrapped together is what in this paper we call a technology service. And I looked at this when I thought about soft systems, and I thought, well, actually, as I've already touched, information security I gave you is a very simple example as for being a system, and all of these can also be systems. You can also think of these as systems, and okay, well maybe this is a good way of thinking about information privacy failures. So then made me think about, okay, I can come up with a privacy-specific performance system model. We've got a project once, so let's have a privacy one. So this has exactly the same components that I showed earlier. We've got the system here, which I then call a technology service privacy system, and the technology service privacy system is effectively the layers of the layers I showed, the 4 layers I showed you on the previous slide, which was this one. So it's the bottom 4 layers. That operates within a wider system, which is the information privacy culture system. So that's the information privacy culture system that's working within the organisation. And then again, we've got the system boundary and the wider system boundary between that wider system and the environment. And within the environment, I've got there 2 examples. I've got regulatory authorities and organisations as elements within that environment, but it could be other things like competitors or customers. So these are all things that disturb and influence and attempt to be influenced by the system. So you can see up there, like the regulatory authorities, well, they're going to come up with legislation or orders and supplements and things like that, so that's going to disturb the operation of this system. The organisation will have its own values and beliefs and culture and its motivation for doing things which disturbs the system. But in the same way, the information privacy culture system might attempt to influence data protection law, investigations, and things like that. So we can then start putting some sort of tangible things within this technology service privacy system. So here we've got the 4 layers, which were in the previous model. So these are subsystems that carry out transformations, and then you've got the privacy decision-making subsystem. Now this approach can be used for both development and ongoing operation. So in development, this privacy decision-making subsystem might just be someone in the development team who is very aware of privacy, has gone undertaken privacy awareness training, and understands privacy by design and manages the privacy of the whole project. Or it could be a dedicated someone from a dedicated privacy team within the organisation. But that privacy decision-making subsystem will again decide on what transformations need to be carried out, provide resources. So I've got a few just examples here. So provides resources. It might be things like privacy awareness, usable privacy control mechanism, makes known expectations. Where it expects things to be done to fair information practices, privacy by design principles, things like this. And then the overall organisational information privacy culture system will do things like the general principles of information use, make recommendations for privacy tools to provide them, and things like that. Okay, so the advantage of this, how can we use this then? So it's just a couple of very simple examples here. So I've got here the boundary between systems. So we've got the wider system boundary here. So a failure of a privacy system might be a case of there's been a failure to appreciate how technology services will be decoded from multiple perspectives. So decoded is very much a social scientist term, but it's how users will perceive a technology service and use it. Certainly a lot of privacy, people's feeling of privacy invasions can come out of this. Failure to consider users' privacy norms within different contexts. So this is the idea of privacy as contextual integrity. And it's just a failure to consider users' social norms and behaviour, things like that. Something like that. This provides resources for legitimate operations. That could be a failure to provide adequate resources, so the company's just not serious about providing adequate resources for privacy by design, doesn't provide sufficient privacy by design tools, doesn't use external privacy practices, Okay, so conclusions. Try to keep this up. This has obviously been a very, very brief introduction to the predictable system model because I've tried to give you a very, very quick flavour of soft system methodology and how that can be used. In the paper, I do actually do a very brief proof of concept for Google Buzz. I look at some of the failures where, why I believe Google Buzz was a failure, privacy failure. So hopefully I've shown this idea that I think systems thinking can be a really useful tool to holistically look at why privacy failures happen. And then the other thing which I think is quite exciting is once you start thinking about systems, you can start thinking about its wider application in privacy research. So many of you will be aware of the idea of privacy calculus and people making a sort of cost-benefit trade-off in terms of information and benefits received. But then that itself is subject to psychological distortions and the idea of behavioural economics. So you almost got a privacy calculus system, if you view it as a system operating with a wider behavioural economic system, which is sort of linked to through a trust signal system to an organisational practice system, and then that's all linked to a technology adoption system. And actually, I think it has a great potential to almost provide as I said, a meta framework for us to start to slot in different areas of privacy research and understand a really big picture of how they all fit together, rather than just being individual separate tools. Okay, thank you very much.
So, before we move to a general discussion with all the speakers, do you have a specific question for Tony on his presentation? Any elements you would like to clarify? No? Everything was crystal clear. Thank you very much, Tony. Okay, so let's move now. We have, let's say 10 minutes of overall discussion about the three presentations we had today. I will maybe shoot first. I have a couple of questions. First to Sophie, maybe, for sure, I misunderstood the point. I had a feeling that there was a rather ambiguous or blurring situation in your explanation between the need to respect confidentiality of this payload data, and then the fact that for security reason, the operator, let's call it like that, needs to dig into this in order to detect malware. This is usual. Because as far as I remember, and you mentioned it to a certain extent, there are exceptions to this confidentiality, and one of them is definitely the need to guarantee the security of the communication, blah, blah, blah. Okay? So for this exclusive purpose, we can accept that the operator, the ISP, will dig into this on an automatic way, hopefully, and for very targeted, specific purpose, which is to guarantee the security of the communication. So, can you clarify it, or maybe I misunderstood it? Because I had the feeling that you were claiming the fact that it's unlawful, this specific activity, but I have the feeling that it's lawful.
I was not saying. I'm saying that the legal framework is not clear. So I agree to some extent what you said. If I look at the e-privacy directive, for example, it says there is this principle of confidentiality. And then it regulates the way traffic data are processed. And I agree, although it's not that clear within the e-privacy directive, that it doesn't mention network security purposes, expressly it's traffic management. And even though the way that it's formulated, it's not that clear. You find network security, I think, in the recitals of the new regulation, but within the e-privacy directive, although it's not clearly mentioned. But assuming that was mentioned, and assuming that was mentioned alongside traffic management, that is only for traffic data. So for the payload, no. But if you look at the practice, this is what they need to look inside the payload to.
So you are saying that there is a kind of a loophole, legal loophole.
But there is an absence of logic, yes, at least. I'm saying that. Yeah.
You want to,
So you say that ISPs feel the need to and the public infrastructure they are operating. So, which, I mean, in a corporate network, you just start a user and then you do the API. So this is some practice layer. For network that is kind of public infrastructure, which is not, of course, it's their network because they own the cable, but it's not critical for them if now they're traversing this network from here. Are there actually cases of ISPs doing the API, doing the argument, or securing their customers?
Well, I haven't gone into that detail. What I've been told is basically that, yeah, I don't want to really extend the practices differ in relation to the scope of the network. That's really their own network, or that's also, that could be also qualified as a public network. Network security is defined very broadly. So that would be one question that I would ask, and I don't know whether to which extent that changes the picture.
As I say, I may be able to partly answer that question because I know I close to work for BT, and I know in recent years we started to provide what we call clean pipes, so clean network pipes, because customers wanted data connections that have been checked for malware and everything else. But I don't know whether they use DPI. I've been interested. Question to ask whether you got a strange situation there. The customers want the inspection.
Yeah, I mean,
I wanted to explain the customer knows that.
Yes.
On this end, I mean, most providers sell this as a value-added service. That you get a clean pipe and you sign that, and that's the agreement. I mean, that's not arbitrary DPI on a customer that doesn't know. I mean, it's a service the customer actually booked. So in this context, the customer may not have a really informed consent because they don't necessarily understand DPI and what's happening there. But it's in the end, it's a contract at least.
Okay, I must say that I was asking the question because I didn't mention any ISP. You mentioned one, but a couple of years ago there was a kind of controversial situation where the ISP were going beyond this limited purpose of security, using the same tool for targeted advertisements. I will name nobody there.
It was one of the
but I'm sure yes.
Popped up, yeah.
yes. Okay, and I have a question also for Tilman. You spoke about this third party, and you call it opener, the one in a position to analyze. What would be your recommendation in order to consolidate and get a trustworthy opener? What will be the main characteristic of this third party?
Well, it's an interesting question. It's also kind of philosophical because you need an entity. So in theory, we always call it
in 6 minutes.
6 minutes. Thank you.
In theory, we just call this entity a trusted third party, and in practice, it's really hard to define who is a trusted third party and who actually extends this trust to the party. I'd say yes, we need an independent entity here. I wouldn't necessarily say this may not be privately organized, but the interest must be very clear here. So yes, it's actually a decision that should be made by a society, because if you want to have something like that, it's a political decision, and actually I would rather see this decided on this level to have broad consideration.
Okay, so the third party will be selected by, as you said, political decision or societal decision.
I mean, in the end, if you create legislation that protects this entity, then you're already in a legislative process where you can also define this entity. I'm not sure if this leads to the best result, but it will at least lead to a result that has a democratic backing.
I don't want to abuse of my position of chairman and my privilege to raise a question. I have one for Tony, but if you have any questions, please just raise your hands. No? Okay. Yes, you trigger my curiosity because you spoke about proof of concepts. It's not a critical your presentation, or rather theoretical. But can you tell us a little bit more about this proof of concepts?
Well, yeah.
Yeah, you spoke about Google, but
Yes, as I say, the idea of the paper really, because one of the things that I was very surprised at is there's a fair bit of literature on using soft systems to look at failures, and so there's this well-established field of work called systems failure. And actually, if you look up, just do a literature search on privacy failures and soft systems, there's hardly anything. It's almost it's close to zero, which just seemed to me very strange. So that was part of the motivation to do the paper. And so really, what I'm trying to answer your question is to say that I'm positioning the paper as actually I think we in the privacy community are missing a big trick. So it was a way of saying this is what it can offer us. And in terms of proof of concept, it was just looking at because I think Google Buzz is quite interesting, and I say in the paper because obviously I've got the limitation. I can only look at press reports, so I'm going to obviously get a filtered view, and that's what I can work on.
I didn't get any information from Google.
I can't understand Google's internal development processes and power plays and everything else. But it is interesting that a very sophisticated company like that made that mistake. There was that failure somewhere, and I'm not attributing blame, but from the outside, it's just how did this happen? And I suspect it's probably a very complex interplay, maybe competitive pressure, maybe engineering mindset, or whatever it might be. So again, it's this holistic interdisciplinary approach. So in my proof of concept, I've just shown very simply how this could be used to start to pull that apart and look at maybe where some of the problems. It's by no means exhaustive, and I think it would be really interesting to use this kind of technique in anger on a real situation when there is a good supply of information.
Okay. No more questions? Okay, I just would like to invite you to join me to thank and congratulate